So good morning, everyone. This is Jagdish, Assistant Professor of EC Department at the College of Technology, Coimbatore. Today, we are going to discuss about the clocking and IBO interfaces in VLSI testing and design for testability subject. So come, let's get into the topic. So what is clocking? Clock, the key to synchronized system. So clock helps the design of FSM, that is finite state machine, where output depends on both input and the previous state. Clock signals provide reference point in time, define what is previous state, current state, and next state. So here in this given diagram, so the clock signal is given. The first that is on state, that is previous state, and the next one is on state is current state, and then next state is the future output. That is given over here to know to have the reference for previous state, current state, and the output state. We need to have this clock signal. So it is the key to synchronize the systems. And what is the difference between latch and flip-flop? When the clock is concerned, we have the term other terms like latch and flip-flop. So what is latch? Latch is nothing but stores data when clock is low, and flip-flop is stores data when clock rises. So the difference between latch and the flip-flop. So the typical clock system consists of this one. Say we have PLL and system clock is given over here, and this is global clock. The enabling pin is there, and there are several logic gates uh, constructed, designed for to make the typical clock system. So next thing is clocking overhead. Latches and flip-flops slow down the clock signals. So the flip-flop delays the slowest signal by the setup clock queue delay. Latches delay the late arriving signal by delay through the latch. So there is D input clock, then Q output is there. So flip flop which enables only the T hold time. The T hold time we have T clock minus Q, and flip flop that's a T setup. So latches we have TD minus Q. So this could be the difference. And next thing is input and output and interfaces. Input and output interface is used to use a method which helps in transforming the information between the internal storage devices, its memory, and the external peripheral device. A peripheral device is that which provide input and output for the computer. It is also called input-output device. For example, a keyboard and a mouse provide input to the computer are called input device, while a monitor and a printer that provide output to the computer are called output devices. Just like the external hard drives, there is also availability of some peripheral devices which are able to provide both input and output. The best example of input and output devices and interfaces is nothing but of when you take your desktop computer system, the computer system which has several units like central processing unit, output unit, input unit. So the output unit, the best example is your monitor. The input unit best example is the keyboard. So the keyboard is a input device, and the monitor is the output device. So to process the input signal, we have a CPU, that's a central processing unit. The process after processing, that processing data must be displayed. So for displaying or the consoling, we have a output device called monitor. So to have the connection between input and the output and the memory unit and central processing unit, we need to connect with some cables or connectors. That is called as the connector is called as interfaces. So interfaces in specifically here, it is nothing but of a bus. Bus is nothing but a collection of conductors is called a bus. Here there are several buses are there. That is I by O bus is there, address bus, data bus, and control buses are there. According to the our application, our need, we can choose either one of the one type of the buses for the interfaces. So, input-output interface in a microcomputer-based system, the only purpose of peripheral device is just to provide special communication links for the interfacing them with CPU. To resolve the difference between peripheral devices and CPU, there is a special need for communication links. The major difference are as follows. The nature of peripheral device is electromagnetic and electromechanical. Nature of the CPU is electronic. There is a lot difference in the mode of operation of both peripheral devices and CPU. There is a synchronization mechanism because the data transfer rate of peripheral devices are slower than CPU. In peripheral device, data code and formats are different from the format in the CPU and the memory. The operating mode of the peripheral devices are different and each may be controlled so as not to disrupt the operation of the other peripheral devices connected to CPU. So this is the special need of additional hardware to resolve the difference between CPU and peripheral devices to supervise and synchronize all input and output devices. Functions of input and output interfaces. It is used to synchronize the operating speed of CPU with respect to the input and output devices. It acts the input and output devices in appropriate for the interpretation of the input and output signal. It is capable of providing signals like control and timing signals. In this, data buffering can be possible through data bus. So there are various error detectors. It converts serial data into parallel data and vice versa. It also converts digital data into analog signal and vice versa. Thank you.